Let's find the volume of the solid of revolution obtained by rotating the region bounded by the parabola y equals x squared, the line y equals x, and we're going to rotate this region about the y-axis. So to sketch the region, it's not very difficult. It's made up of two of the basic functions. Here's y equals to x squared in the second quadrant, but we need it in the first quadrant. And here comes the line y equals x. They intersect at two places. We can find the points of intersection by inspection, or we can set the right hand sides equal. So x squared is set equal to x. Move everything to the left, so x squared minus x is 0. Factor x. X times x minus 1 is 0. X equals 0 and x equals 1. But this time we're going to need the y coordinates of the points of intersection. So when x is 0, y is 0, and of course when x is 1, y is also 1. Here's our region. It will be rotated about the y-axis. So what we want to do is sketch the region again without any extra stuff, just the region itself. And so here it is. This is the parabola part, and this is the line part. And the axis of rotation is the y-axis. We want to sketch what will happen to this region 180 degrees into the rotation. So reflected about the y-axis, it looks like this. This is y equals 1. Keep track of a typical y between 0 and 1. Always go back to the original part, the original region. Keep track of this horizontal slice of the area. 180 degrees later, it'll end up over here. And let's sketch what it generates, a cross section that it generates. In the middle, there will be nothing. And right over here, between the two circles, this is the washer, we're going to get some area. And if we give it a little bit of thickness, which we call delta y, we're going to get a cross section of the volume. So recall that whenever we have a washer with an outer big circle and then a hole in the middle, and the inner radius is little r and the big radius is big R, the area between the two circles is pi big R squared minus pi little r squared, or pi times big R squared minus little r squared. Now what we're going to do, since we'll be integrating with respect to variable y, we need to solve for x in terms of y. When y equals x, there's nothing to solve. X equals y. When y equals x squared, if we take square roots of both sides, we end up with x equal to plus or minus the square root of y. So there are two parts to the parabola. The negative square root of y lies in the second quadrant. We don't need that. The positive square root of y is the part in the first quadrant, which is what we are going to use. So x equals square root of y is what we're going to select. Now let's return to our region and sketch it one more time with 180 degree rotation included. So here it is right over here again. And this is the graph of x equal to the square root of y. This right here is the graph of x equals y. 180 degree image lies here. Here's 1. I'm picking a y right there and looking at this horizontal slice. I'm going to draw this washer once again. And let's find the area of this washer. So the big radius, if we were to draw this, extends all the way to the parabola. So the big radius for a given y is the x-coordinate on the parabola, which is the square root of y. The little radius is the y-coordinate right over here. It's a distance from the axis of rotation from the y-axis over to the line. So that's when r is y. And so we're going to integrate from 0 to 1 pi times big radius squared, so square root of y, quantity squared minus the little radius squared, that's y squared, and integrate this with respect to y. So this is equal to pi times the integral between 0 and 1. Square root of y squared is y minus y squared dy. So this is pi times 1/2 y squared minus 1/3 y cubed, evaluated from 0 to 1. Plugging in 0 we get 0, plugging in 1 we get 1/2 minus 1/3, which is 1/6. So the final answer, the volume of the solid of revolution, is equal to pi over 6.